The CLO for this lesson is students will be able to graph in writing quadratics using vertex form and key features with the following language: if-then statements, vertex form, quadratic parabola, x-intercept, y-intercept, and vertex. So, in your own words, what do you think we're going to learn how to do in this lesson? So if we begin with the vocabulary words, vertex form is a quadratic form that looks like so A is just any number in front of the parentheses. Then in the parentheses is going to be an x plus an h, and there's one parentheses that's going to get squared. And then there's usually some number getting added to the end. And that's how you know it's vertex form. Mostly it's the parentheses getting squared. So in order to make a good quadratic graph, we are going to want our three key features. What is the x-intercept? Click all that apply. Remember, x-intercept is where the graph crosses x-axis. Also, that means y equals 0, because if it's on the x-axis, it's not going to be going up or down at all. And then, what is the y-intercept? The y-intercept is where the graph crosses the y-axis. Therefore, x is going to be 0 because it's not going to go left or right. It's going to stay on the y-axis. And what is the vertex? The vertex is the top or bottom of the hump. It's also the maximum or minimum of the graph. Let's talk about how you're going to quickly get the key features from vertex form so that you can graph instead of guessing and checking points to plug in. So for x-intercepts, remember the whole thing is that y has to equal 0. So if I took something like this and made it 0 equals 0, do you remember from the last unit how you would solve this for x? You would just use backwards order of operations to isolate the x, and that's how you solve for them. For the y-intercept in the vertex, remember it's when x equals 0. So really all you do is you plug in 0 into this x and then solve. So for the y-intercept, it's plug in 0 to x and put it into the calculator. All right, the vertex is the special one in vertex form that you can get pretty easily. For the vertex to get the x value, make the parentheses equal 0 and solve. And then for the y value, just equals the k, the letter at the end. Like in this case, it'd be the -9. But remember, you always want to write them as points. So like for backward or just order of operations, you're going to always get two answers. And so for x-intercepts, it's going to be answer 1, 0, and then answer 2, 0, because the y is 0 for x-intercepts. For y-intercepts, we're plugging in 0, so the x is 0, and then the answer from the calculator is the y. And then for the vertex, again, when you write it as a point, to get the x, it's because the parentheses equaling 0, and then the y value is just the k. All right, so let's do some examples of figuring these out in graphing. So x-intercepts, I'm just going to do backwards order of operations. So the equation is x minus 2 being squared minus 9. I'm going to make it equal 0. Now I need to solve for x. So that's my first step. I have to add 9 to both sides. So then I still have x minus 2 getting squared. Then it's going to equal 0 plus 9 is 9. All right, what's my next step in solving for x? To get rid of the squared, I have to take the square root of both sides. So the square root canceled the squared. Therefore, I'm just left with the x minus 2. On this side, I have to take the square root of 9. So if I do the square root of 9, I get out the answer of 3. However, I cannot forget that when it's square roots, it's also negative 3. So now what is my last step in solving for x? I have to add the 2 away to both sides. So then on this side, the minus 2 plus 2 will cancel. And then so I'm just left with x equaling my 2 answers. And then 3 plus 2 is 5. And negative 3 plus 2 is negative 1. So when I write my 2 x-intercepts, it's going to be 5, 0, and negative 1, 0. And just to quickly prove to you, if I take the equation x minus 2 squared minus 9, if you look, here's the negative 1. Here is the positive 5, like we got when we solved negative 1 and the positive 5. But also, if I put negative 1 in here, the answer becomes 0. And if I put 5 into that x, the answer is also 0. But any other x, like 1, oh look, the answer is not 0 anymore. So those are the 2 x values, negative 1 and 5, that you can put into that x and get out the answer of 0, which is why the y is 0, because that's what we were looking for. So here are our x-intercepts. Now for the y-intercept, when I take the equation, which is x minus 2 squared minus 9, and I'm going to plug 0 into the x. I'm going to put 0 right here. Whatever answer I get out is my y-intercept. So if I take this and I put 0 where that x is, answer is negative 5. So my y-intercept is going to be, when I plug in 0, I get out negative 5. And finally, for the vertex, for the x value, I have to take the parentheses and make it equal 0. So the parentheses right now is x minus 2. I need to make it equal 0, and then I need to solve for x. So I just need to take what's in the parentheses part, the x minus 2, and make that equal 0. So how do I solve for x? Well, first I have to add the 2 over, because negative 2 plus 2 is 0, so that cancels. But I also have to do it to this side. So then I end up with the answer that my x is going to equal 0 plus 2 is 2. So I found my x value. Now to find my y value, it's just the k, the number at the end. So in my equation up here, my k, my number at the end is negative 9. So the answer is going for my vertex is going to be the 2 that we solved for, and then the negative 9 from the k. And so that's my vertex. So now that I've found all of my key features, I'm going to make the graph. using the key features. So I have a couple options. If I did it on graphing paper, so let's say I'm going to make a graph of this and I'm using perfect graph paper. So I have the 0.50 that showed up right here because from the middle it went right 5, but it's not going up or down. I also have the point -10. So I can put a -1 and 0, and then the point shows up right here because it went backwards 1, but then not up or down. Next is 0, -5, which ends up down here because I'm not going left or right, but I am going down 5. And then my vertex is at 2, -9. And so I need to scroll out to see it just a little bit. So it's right here. So my vertex is where I would hoop at. And so I'd hoop up from this point to connect my dots. But if I just put the graph in here, you can see now it choosing to connect the dots, the red dots, and it curves right at that vertex. So this is a picture of a perfect, pretty little graph. If I was doing it by hand, I always need to make sure to label my X and my Y. And I always have to label my tick marks. So for my vertex, do you see how it goes all the way down to -9? So I need to be able to go down 9. So why don't I do all 9? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that's a -5, that's a 0, that's a 0. So I'm not going to have to go up at all. So this is -9. For my x's, I have to go at least forward to 5, -1, 0, 2. So at least 5 in the positive direction. 1, 2, 3, 4, 5. And then at least -1 in the negative direction because of this one. So this one's a -1. This one's a +1. So you always want to label at least your first tick on all of them so that they know what your scale is, that you're going by ones for every tick mark. Then after that, I just like to label the ones my points are at. So for example, this 5, 0, I'm going to come over here and label this guy 5. So that when I put a point on it, it's clear what point it is. Just like this -1, 0, the -1's marked. 0 and then -5. So -1, -2, -3, -4, -5. So then I'm going to go ahead and label this point at -5. And the next one's 2, -9. So my -9's marked, but I'm going to come mark my 2 right here on my X before I put the point 2, -9 down here. Then now that I have my 4 points, I just have to remember to curve at my vertex. So I'll curve up here, and then curve up here. And it's nowhere near as pretty as it would be if I made it on graph paper, but it's still the graph. Okay, so next we need to graph this equation. So it's almost like the other one, except I put an A in front, a number in front of that parentheses. So I can show you how it changes the steps just a little bit. So we're going to start with the x-intercept. To find the x-intercept, so you're going to take the equation and you're going to make it equal what? It equals 0. And then I need to solve for x. So when I solve for x, what's my first step? To get rid of this plus 12 by minusing it away to both sides. So now I have -2 parentheses x plus 5 being squared. The plus 12 minus 12 cancels and eliminates. But then over here, 0 minus 12 is negative 12. Now what's your next step in solving for x? You have to divide away the negative 2 in front. You can't get rid of the squared yet because this negative 2 is not in the squared. It's outside of it. So you have to get rid of the negative 2 first. Negative 2 divided by negative 2 will become 1. So you just have one of the parentheses, the x plus 5, that's being squared. And then on this side, negative 12 divided by negative 2, a negative divided by a negative will become positive, and 12 divided by 2 is 6. So now what's the next step in solving for x? To get rid of the squared, we have to square root both sides. Square root and squared will eliminate, so that for this one, on the left, all I'm going to have is the x plus the 5. And then on this one, I have to take the square root of 6. So the square root of 6 is 2.449. So I'm just going to just do the 2.44. I don't think we need to round for this one. It's fine. But don't forget, it's also negative 2.44. What's the last step in solving for x? We have to get rid of the plus 5 by minusing 5 to both of my answers. So on this side, the plus 5 minus 5 will eliminate. We find out that x is going to equal 2.44 minus 5 is negative 2.56. And negative 2.44 minus 5 is negative 7.44. So my two x-intercepts point is going to be negative 2.56 comma 0 and negative 7.44 comma 0. Next, we're going to do the y-intercept by taking my equation, and instead of x right here, what do we put? 0. And so if I put this into a calculator, it's negative 2 parentheses 0 plus 5 squared plus 12 is negative 38. So the y-intercept, when I plugged that in 0, I got out negative 38. And for the vertex, to get the x value, remember we take the inside of the parentheses. So in this case, it's going to be x plus 5 that's inside the parentheses. And you make it equal 0. So then how am I going to solve for x? You minus the 5 away. Because plus 5 minus 5 eliminates. And then you're going to end up with the answer of x equaling 0 minus 5 is negative 5. So that's the x value of the vertex. It's going to be negative 5, comma. And remember, the y value is just the k at the end. So just this plus 12. And so it's just going to be positive 12. And those are my 4 key features. So I grabbed the 4 key features right here from the work we did. And we're going to make a graph now. This graph is going to look way prettier on Desmos because it's all decimally. So for this one, I have negative 2.56 with 0. That's right here. I have negative 7.44 with 0. So that's right here. I have 0 and negative 38. Zoom out for that because that's all the way down here. And then for my vertex, it's negative 5 and 12. Goes up there. So now you can kind of see the graph. If I were to put the whole equation, there it is. So that's a picture of the graph. I'm going to go ahead and show you if we try to do it by hand. So we're going to want to label X and Y. For my X's, to figure out their scale, this is negative 2.5 about. This is about negative 7.5. 0, negative 5. So I only need to go in my negative direction for my X's, and I'm only going to go up to like more than negative 7 would be negative 8. So I'm just going to go backwards 8 tick marks. So my X scale is going to be by ones. So this is negative 1, and then 2, 3, 4, 5, 6, 7, 8. So I'm going to write negative 8 by this one. All right. And then for my Y's, I have 0, 0, negative 38, and 12. Well, 38's a lot. And I'm not going to do 38 little tick marks. So what if I try to go by something else? Like 38. If I tried to go by 2s, that would still be 19 tick marks. Try to go by 3s, I need at least 12 tick marks. Why go by 3s? What if I went by 5s? Well, then I only need about 7 point something tick marks. So let's go by 5s. So for my Y's, my first tick mark is at 5. Each one's worth 5. So then this is 10. And here's 15. And in my positive direction, I don't have to go up anymore because it only goes up to positive 12, like this point here. My negative direction, though, I need to go down at least 38. So if this is negative 5, here's negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40. So going down to 40 gets me to at least 38. If I want to graph these points now, negative 2.56, it's about 2.5. So negative 1, negative 2, and about a half is right here. And I get to put the point because 0 means I'm not going up or down. So to plot negative 7.44, 0.44 is like 44 cents, and it's close to half. So I'm going to estimate it about 7.5, negative 7.5. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And about a half more would be about right here. Then 0 and negative 38. So when x is 0, so I'm not going left or right, but I am going down 38. Well, here's negative 40. So it's a little bit before that. And then finally, my vertex is at negative 5. So I have to go backwards 1, 2, 3, 4, 5. But then positive 12. So then I have to go up. Here's 10, a little bit more, would be about 12. Because of this point, I would probably put a negative 5 right here, just so that it was clear. And then finally, at your vertex is where you're going to hump. It's going to hump down because of where the other points are. So there, there. Try to make it look the same on both sides. It's very hard. This is supposed to U at the top, and it kind of looks more like a V right now, but a U would have been better. It's hard for me to control things on here. Like I can't make my eraser smaller. But you get the point. And that's this one. So go ahead and use the words in the CLO to explain to me what you learned how to do in this lesson.